Hello friends and welcome to edupediaworld.com, your favorite destination for online education. This session we're going to see partition values. We shall see what partition values are, what are some of the common partition values, and how to calculate them. So let's begin with the understanding of what partition values are. Well, partition values divide the given set of data into a certain number of equal parts. When we talk of dividing the set of data into certain number of parts, what comes to mind is the median. Yeah, because median divides the data into two equal parts. It is a central tendency value, which is the midpoint, which falls at the center of the data, and it is a locational measure or a positional measure. So can median be called a partition value? Yeah, of course, median is a partition value, and we do have several other partition values which could divide the data into more than two parts. For example, we have quartiles, which could divide the data into 4 parts. We have deciles, which divides the data into 10 parts, and we have percentiles, which divides the data into 100 equal parts. Now these partition values are also called as fractiles. So let's see how to calculate the various measures of partition values. Basically, we will see the three different types of partition values, starting with quartiles, which divides the data into 4 equal parts. Thereafter, we will see percentiles and of course deciles. Now when you have a set of data, let's say this is the line representing the data starting from the lowest, say from 0 to say 100, and if we have to divide it into 4 parts, I need to place 3 partitions, one in the middle, one here in the first quarter, and one in the third quarter. The middle one, of course, we know is the median. Here we call this as the first quartile, Q1, this as the third quartile, and in between, of course, we can also call this as the second quartile, which corresponds with the median. Okay, now the partition values, as we have seen that even median is a partition value, so the treatment of calculating a partition value from a given set of data is same as that of median. Deciles divide the data into 10 parts. It's starting from say D1 to D9, and in the same way percentiles divides the data into 100 equal parts, and the symbol for that is P, starting from P1 to P99. Now let's see how to calculate these measures. As I said that the treatment is same as that of the median, we will follow the same procedure which we had for median, and in fact when we solve a problem you'll realize that there is nothing new in this. Let's take for example the quartiles. Suppose if I have a set of data, and if I have to divide it into, if I have to find the quartile values Q1, Q2 and Q3, what I do is, since there are 4 now, the total data, the n, we have n is the total number of data, right, which we have been using. So n would be divided into 4 parts. For median we used to take the total number of data divided by 2. Okay, here for quartiles we will take n divided by 4, and depending on which quantity I want, I will multiply this value. So in case if I want Q1, I will multiply it by 1. If I want Q2, I will multiply it by 2. so it will be 2n by 4, and this 2n by 4 is nothing but n by 2, which is same as that of median. And for Q3 it will be 3n by 4. Similarly, deciles, we will divide the data into 10 parts and multiply depending on what we have. Let me give a variable here I. If I have to find the second decile, I'll multiply this by 2. If I have to find the fourth decile, I'll multiply it by 4, and so on. The same is the treatment with percentile. So let's take a couple of problems and practice finding a few of these quantities. Now the case of raw data is trivial, and the treatment is same as that of the median. So let's take up a couple of problems and solve. Alright, so here we have a question which has got some variable x and then their frequencies. So let's find the two quartile values, any two decile values, and two percentile values. Or let's begin with finding the median. That would be easy. So what we used to do to find the median? Exactly, we first sum the values of frequencies. This is the sum of frequency 200, and then we find the cumulative frequency. The cumulative frequency is the sum of the frequencies up to that variable. So the first one, it's 15. The second one, it is 15 plus 20. It's 15 plus 20. Third one is 15 plus 20 plus 32. Of course, 15 plus 20 is 35, plus 32 is 67, and so on. I can just drag the same formula into all of these cells. Well, so these are my frequencies. Now to find the median, your n is an even number, so what we will have to do is we will have to find n by 2, and n by 2 plus 1. Okay, so that means I need the 100th and 101st data. My 100th data, if I look in the cumulative frequency, happens to be the one corresponding to this. And even my 101st data corresponds to 78. Therefore, my median would be 78. Exactly. Let me write that here in a separate column because we have so many. So median is, and this is also my second quartile. So now to find the first quartile, again the same treatment. Do we need to find n by 2? No. When we are finding the quartile, we will have to divide it by 4. So it will be n divided by 4. And then for the first quartile, I'll multiply it by 3. For the third quartile, I'll multiply it by, sorry, for the first quartile, I'll multiply it by 1. And for the third quartile, I'll multiply it by 3. So my Q1 would be n by 4. So n by 4, of course, this is a trivial number, we see is 50. Yeah, and so my 50th data lies here, and also my 51st data. So this will be my Q1th class. Let me write that here, Q1th class. This is my median class, or Q2 class. So my Q1 would be 77. In the same way, let's do and find what is Q3. We will have to multiply it by 3. So my n, 3n by 4 for Q3, 3n by 4 will be 150, and the data corresponding to 150 is 80. So this is my Q3 class, and my Q3 is 80. In the same way, if I have to find, let's say, D4, yeah, what do we do? For D4, we need to find 4n by 10. So it will be 4 multiplied by n, which is 200, divided by 10, because D and deciles divide the data into 10 equal parts, and that happens to be 80. So the data corresponding to the 80th frequency will be my D4. So where is my 80th frequency? 35, 67. My 80th frequency also corresponds to this class. So let me write that here. This is my D4 class. Yeah, so again my D4 would be, let me put this near to D4. My D4 will be 78 again. Similarly, let's find a percentile value. Let's say, let's find P90, the 90th percentile. Now for 90th percentile, as we know, percentile divides the data into 100 equal parts. We will have to divide n by 100, and since we want the 90th position, we will have to multiply that by 90. So this will be equal to 90 into n by 100, and that is equal to 180. So my P90th class is the one where the cumulative frequency is 180. So 180 happens to be in this class here. So let me give a different color for this. Yeah, and let me give a different color for, well, these two are the same. So this is your P90th class. And my P90 happens to be 82. Hope that's clear. There's no confusion. Of course, even and odd we will treat as we had treated the median. We have been taking two. It's for P90 we take 180, the average of 180 and 181. Both of these falls in this class. Similarly, for D4 we took both 80 and, well, for D4 it was, yeah, both 80th and 81st data. Similarly, for Q1 we took 50 and 51st data, the average of 50th and 51st data, and so on. Alright, so let's go now to grouped frequency distribution. Before that, let me just recollect the formula which we had for median, and we will be using a similar formula. For median, we used to, the formula to calculate was lower value of the median class plus n by 2 minus cumulative frequency before the median class divided by frequency of the median class multiplied by width of the median class. Okay, in the same way, to calculate the formula for quartile, deciles and percentiles would be similar. The only thing will be that for quartiles, let's say qi, I'll have to take the lower value of the quartileth class plus, instead of n by 2, now I will have n by 4, because quartile divides the data into 4 equal parts, and that would be multiplied by whichever quartile quantity I'm finding, whether it's first, second or third. So it will be I n by 4 minus cumulative frequency before the quartileth class qi divided by frequency of the quartile class multiplied by the width of the quartile class. Let me write it as HQI. Okay, I'm sure you are well aware with the nomenclature and I don't need to write them here. Let me just repeat. When I'm finding the quartile, whichever quartile quantity I'm finding, I'll take the lower value of that class plus the only change from median to all these set of formula is this quantity. Rest everything is the same. So it will be n by 4 and not n by 2 multiplied by the quartile measure which I am going to find, I, minus cumulative frequency before the quartile value, the quartile class, whichever quartile, the quartile class, and then frequency of the quartile class multiplied by h, that is the width of the quartile class. Similarly for deciles and percentiles, the only difference is that we will take n by 10 and n by 100. For deciles, say di, we will have lower value of the decile class plus I n by 10 minus cumulative frequency before the decile class divided by frequency of the decile class multiplied by the width of the decile class. And for percentiles, let me do that here. We'll have to take the lower value of the percentile class, which and then followed by, this time it's n by 100 times I minus cumulative frequency before the percentile class divided by frequency of the percentile class, and that will be multiplied by h. Let me write that here, h of the percentile class. Okay, so these are the formula which we have for the partition values which we are seeing today. So let's solve a problem based on this, and we don't really need to worry about it because the treatment is very similar to that of median. Once we have learned the median, this is just a matter of solving a few questions. Alright, so let's take this question and let's find out say Q3 and say one of the deciles value, say D6, and one of the percentile values, say P70. Okay, now what do we need to do in this? First, of course, we will be adding the frequency here. Remember, I had told you that for median we need to arrange the data in ascending order. That's valid here as well. Next we need to find the cumulative frequency. This is 15. The next one would be 15 plus 40, and then we can drag it down to all the remaining cells. Yeah, so I've got my cumulative frequency, I've got the total frequency, that is n. Now for Q3, I need to find Q3. For Q3, I need to divide my n by 4 and multiply it by 3. So 3n by 4 will be equal to 3 into n divided by 4. That's 375. So I need the 375th data from here. Of course, we will get the class, and then from there we will have to use the same interpolation formula and calculate the values. So my data from 1 to 15 falls in this class, from 16 to 55 here, from 56 to 90, from 91 to 150, 151 to 275, and 276 to 375 falls in this class, that is from 300 to 350. So let me give a color for this. For Q3, this is my Q3 class. Say Q3 class. Okay, now let me do the calculation here. I need the lower value of the Q3 class, which is 300, plus I need 3n by 4, which is 375, minus cumulative frequency before the median class, which is 275, divided by the frequency of the median class, which is, sorry, not median class, I'm sorry, I've been saying the median class all along because got used to it, but it's the Q3 class. So 300 plus n 3n by 4, which is 375, minus 275 divided by 100, and the whole thing would be multiplied by the width of the median class, and the width of the median class we see here is, sorry, again I'm saying median, it's Q3 class. The width is from 300 to 350, the width is 50. So let's do that here. So it's 350. So my Q3 happens to be 350. Let me write that here. This is my Q3. Okay, so next I need to find D6. So for D6, this is for Q3. Let me write here for Q3. For D6, what I need to do, I need to find the 6n by 10th data. Yeah, so my 6n by 10th data would be 6 multiplied by n divided by 10, and that happens to be 300. So 300, where does it fall? Well, again from 276 up to 375, all of that falls in this. So this is also my D6 class. D6 class, let me do that. Let me do the calculation of D6 here. D6, lower value again is 300 plus this value 6n by 10 minus cumulative frequency before, which is again 275, divided by the frequency of this class, which is 100, and the whole thing again multiplied by the width of the class, which is 50. So it's 312.5. So my D6 is 312.6. Let me give it a different color. Yeah, okay, and then finally I need to find the P70 value. So for P70, let's find the class. I need to do 70 n by 100. Okay, so it is 70 multiplied by n, which is 500, and that divided by 100. So it is 350. I need the 350th class. Well, again, it's falling in the same class, the same. You have all the three here. You have the Q3, you have D6, and P70. All of the three are here. So let me do the calculation of P70 here. Lower value is the same, 300 plus 350 minus 275 divided by 100, and then the whole thing multiplied by 50. And my P70 happens to be 337.5. Right, so these are the steps, and I think we really don't need to go through it again and again, because we have already done median and we know how to find the partition values in the same way. So that's all we have in this session. Keep watching edupediaworld.com. Thank you.